In this video, I'm going to show you how to perform a 2x2 between subjects factorial ANOVA in SPSS. Now this example is the one that's based in the textbook, and the dependent variable is punishment, which is a continuously scored dependent variable which is appropriate for ANOVA. And I've got two independent variables, game type and sex. And so game type is coded 1 and 2, which if you look in variable view corresponds to 1 violent, 2 non-violent, and the sex variable is coded 1 for male and 2 for female. So this makes it a 2x2 between subjects factorial ANOVA, and I've got the one dependent variable, which is always the case in a regular ANOVA. So to conduct the analysis, go into Analyze, General Linear Model, Univariate, put punishment into the dependent variable box, and game type and sex in the fixed factors box. Now I'm just going to go through these buttons here to show you the options. First, you've got Model, and there are options here that you might use in some context, but they would be relatively unconventional. The only thing that I'll note is that sums of squares are specified as type 3, which is the default in SPSS, but you also have some other types of sums of squares. And I'm only going to mention this briefly in this video because it will have an impact on one of the results. So click on Continue, and you've got contrast if you wanted to do some contrast analyses, which we're not going to do in this case because we only have 2 levels in each one of our independent variables. Now we can also plot our data with respect to the means in a chart, which is a useful thing to do. So I might want to look at the game type main effect, and I'm going to put that as one of the charts. And I might want to look at sex main effect in a chart, and I also might want to look at the interaction. As I noted before in the textbook, the principal reason people do factorial between subjects ANOVAs is for the interaction. So I'm going to put game type on the horizontal axis and sex as separate lines. This is because there's only 2 independent variables. If I had a third independent variable for something like a 2x2x2, I would use separate plots as the next level of complexity with respect to the presentation of the means. Now, depending on the version of SPSS you have, I have version 25 here, you will have the option to specify or include error bars, and specifically confidence intervals is the default, and that's my recommendation. Some people will put a standard error. I'm not quite sure why anyone would think that would be better than confidence intervals. So keep confidence intervals 95% as the option here, and I'll show you what that looks like in the charts that are produced. If you have a version that is earlier than 25, then you will probably not have this option down here. So it's actually quite a nice benefit that SPSS includes this now, particularly in the context of repeated measures design ANOVAs. You know what, I don't have the game by sex interaction. Got to make sure I include that in there. And there we go. So click Continue. I wanted to look at post hocs. Again, if you had a design larger than independent variables with 2 levels, then you would consider doing some post hoc testing. It's not necessary for a 2x2 between subjects factorial ANOVA. You've only got 2 levels. If you had 3 or more, you could consider it. Click Continue. Now here you've got estimated marginal means, which this button doesn't show up in versions earlier than 25, I don't think, but this option does appear in one of the buttons as an extra option. So depending on the version you have, you may or may not see this obviously. Now you can include the means here, and a lot of people would, and what you're going to get here are the confidence intervals for these means. But also what you have to keep in mind is these are going to be the means based on the type 3 sums of squares approach to doing an ANOVA. So they're not going to be the observed means, they're going to be what are called the estimated marginal means. And so it's going to be a little bit different, and I'll show you what that looks like in the charts and in the tables that follow the analysis. This is important because you might be surprised to see that the descriptive statistics, which include the means and standard deviations, are going to be different than the means reported in this section of the output. So I'll get to that in a minute. Just be mindful that it's not necessarily the same as the descriptive statistic means, especially if you have unequal sample sizes across your groups. So click Continue. I could save some values if I wanted to. Not really interested in that in this case here. And then we have options. We do want to get the descriptive statistics. We do want the estimates of effect size. You probably want observed power just to check it out. And you want homogeneity tests. Now the other options here are potentially useful in some cases, but they're not really useful. Here I don't think that heteroscedasticity tests of these nature, again, depending on the version of SPSS, you won't actually see this. In version 25 it appears. I'm not going to select that here. This is just the basics of a factorial between subjects ANOVA. So click continue, and then you could bootstrap the analysis if you desired. I'm not going to do that here. And again, depending on the version that you have, you might not be able to see the bootstrap. So I'm just doing a regular asymptotic normal distribution theory p-value estimation approach. I'm not doing bootstrapping. So with those options selected, I click OK. And here are the results outputted by SPSS. The first table is a between subjects factor. It's basically telling you the design of the study. And we have two independent variables, game type and sex. And we can see 1 for game type corresponds to violent, and there are 17 participants in that group. The other game type, 2, non-violent, there were 22 people. Now, this study was done in such a way that randomization was applied to include people in the various groups. Why the sample sizes are unequal might be related to maybe somebody didn't complete all the testing, for example, and so the researchers decided to exclude them. So for some reason the sample sizes are unequal, even though they used randomization. So the next group is variable sex. We got males and females, and it's almost an equal number of males and females. Now next, the descriptive statistics. These are the observed descriptive statistics that most people would consider as the representation of the measures of central tendency and standard deviations or variability in data. But I'll show you later, the estimated marginal means are going to be different. So here we've got violent video game playing group, and the males, they had the largest numerical punishment mean. So they meted out the highest decibel noise blast punishment. Males in the violent video game playing group, 7.01. Now I don't know if that's statistically significant from any other mean. I just see that it's numerically larger. And the corresponding standard deviation is 2.28 with a sample size of 8. And so we can get all the descriptive statistics for each of the groups in this table. Violent video game playing females, 5.05 standard deviation here, and sample size, 9. Then we have here the total, and the total corresponds to the whole sample of 17. So if you calculated the average punishment level meted out by those who play the violent video game, irrespective of whether the males and females, just all of them in the same sample, you get a 5.97 mean, and the standard deviation is 1.98. Then you've got the non-violent section here, where non-violent video game playing males produced a mean of 4.6 and a standard deviation of 1.06 and a sample size of 11. Females, non-violent, 4.61, 0.63 standard deviation, same sample size. And then total, non-violent, 4.605, 0.85. Now the reason this is important, this violent video game playing total and the non-violent video game total, is because that is relevant to the main effect of video game type. So did video game type have an impact on punishment, irrespective of what gender somebody is? So just disregarding that information. These are those means and standard deviations that correspond to that main effect. Then we have the total for males and females collapsed across video game type. So if you look at males, they've got a mean 5.6 punishment production value, which is numerically larger than the females, 4.8. Now again, that's if you collapse the two video game types. So just all the males in the whole study, 19, and all the females in the study, 20. What were their punishment levels produced or meted out in the study? And again, this would be a main effect for sex. Now, are any of these means statistically significantly different from each other? Well, we would have to carry on throughout the output to find out. The next piece of information is Levine's test of equality of error variances. Now, in version 25, I believe is when SPSS started producing more information in this. Originally, it was based on the mean only, and you got a value, in this case here, 7.56 with degrees of freedom of 3 and 35, and it's statistically significant. So the assumption of homogeneity of variance has been violated in this case. And I mentioned in the textbook that Bartholow et al. Don't make any mention to violating the assumption of homogeneity in their analysis, which is a limitation of their study, especially considering that the sample sizes are actually unequal across the groups. And I mentioned in a textbook that that's an especially bad case of violating the assumption of homogeneity of variance. Now, for the purposes of this video, I'm just going to carry on as if this isn't a problem, because I talk about this assumption later on in the chapter. I just want to mention this briefly, that you get the Levine's test of homogeneity of variance here, and I'm going to come back to it in more detail in a future video that's later on in the chapter. The next table is the test of between subjects effects, which is really the meat and potatoes of the analysis. Now you can kind of just ignore the corrected model and intercept values here. They're not really relevant to reporting anything with respect to the main effects or interact. Now the first main effect of game type, and going back here, game type, it's comparing this mean here, 5.97 versus 4.6. That's the main effect of game type mean. That is statistically significant because the p-value is less than 0.05. It's actually p equal 0.002, and the f-value is 11.01, and it's got 1 and 35 degrees of freedom. You always look at the error term for the degrees of freedom in the ANOVA, so it's 1 and 35 degrees of freedom. And it's got a partial eta squared of 0.239. You can ignore the non-centrality parameter, and it's got observed power of 0.897. Now the sex main effect, just follow the row. We've got an F of 5.15, and the degrees of freedom of 1 and 35 gives a p-value of 0.029, so we've rejected the null hypothesis again of equal means for sex, which is relevant to these two means, 5.61 versus 4.8. So the two main effect null hypotheses have been rejected. People who play violent video games, on average, whether you're male or female, or I should say disregarding whether you're male and female, is numerically larger than not playing a violent video game, 5.97 versus 4.6. And then the second main effect, males produce or mete out larger punishment values when you collapse across video game type in comparison to females, 5.6, 4.8. Pretty much in the direction that was hypothesized if you read the Bartholow et al. Study about the impact of violent video games and the fact that males tend to be more aggressive than females. Now, the all-important interaction, game type by sex, with 1 and 39 degrees of freedom, yielded an f-value of 5.258 and is also statistically significant, 0.028. And that's produced a partial eta squared of 0.131. Now, I mentioned in the textbook that the partial eta squared for the interaction is probably the only eta squared that you can interpret in the context of a factorial design, and it basically means that 13.1% of the variability in the punishment scores was accounted for by the interaction independently of the main effects. So this is unique to the game by sex interaction. And again, we have the power estimates here. Both of these were less than 0.80, but we ended up rejecting the null hypothesis. Still a bit of a concern that power was so low. Now, I mentioned that I've rejected all these null hypotheses and I'm interpreting the main effects and the interaction, etc. It's not that simple. First of all, the assumption of homogeneity was violated and the sample sizes are unequal. I wouldn't interpret these p-values as they are. I would be concerned as I talk about it later in the chapter. But for the purpose of education, if you follow the Bartholow et al. Study, this is pretty much what they did. And there'll be plenty of other people doing the same thing. Not that it's recommendable. Now, before I get to these estimated marginal means, I want to look at these charts. So this is a line chart. For some reason, SPSS produces a line chart for means that are actually not related. There's no within subjects factor in this design, so I would try to get rid of this line here. You could just report it as a error bars with, you could just get rid of this like that. And then you've got a chart that's a little bit closer to appropriate. There we go. So then you could interpret something like this, and you could show that the violent video game group is larger mean than the non-violent video game group, and the 95% confidence intervals don't overlap either. So you'd have to do a little bit of work to make this chart look a bit prettier and report ready, but this is the main effect of game type. Now, I don't know if I can interpret the main effect of game type because there's a significant interaction. I'd have to, as I discussed in the textbook, conduct simple main effect analyses to verify that the effect is consistent across all levels of the other independent variable. I don't expect you to understand that totally right now if you haven't read the chapter, but I'll mention it at least briefly here. Now here's male versus female. Males score higher than females, and that was statistically significant as a difference, just barely. And what's interesting here is that the confidence intervals actually overlap each other quite a bit actually, but not enough to be a non-significant result. So it's statistically significant, and this is totally plausible to have about this degree of overlap. If it was much more overlap, it wouldn't be significant. And then we have the interaction effect here. This interaction is also statistically significant, And we can see that the mean for nonviolent is almost exactly the same for both males and females. Whereas for violent, we can see that males are producing a much larger punishment score in comparison to the females that also played a violent video game. So it looks like, based as I talk about it in the textbook, do video games actually have an impact on people's tendency to produce violent behavior as a result of playing violent video games? The answer has to be something to the effect of, well, it depends. It depends on whether you're a male or a female. It looks like for males it does have an impact, but for females it doesn't look like it does. Or at the very least we could say, and this would be the more appropriate thing to say, the magnitude of the difference between violent video game and non-violent video game is much larger and is statistically significantly larger for males than it is for females. I still don't know if this is a statistically significant difference between this mean and that mean, so I don't know if the violent video game had an impact on the females or not in a statistically significant way. I would have to follow that up with simple main effect analyses, which I do in a future video. For now, though, I just want to point out that this is a representation of the interaction. The magnitude of the difference going this way is more substantial than the magnitude of the difference going this way. Now, I could have flipped this chart around and had males here and females there, and then had violent video game and non-violent video game. Let me do that very quickly now, just to show you that it's actually going to be the same story, but just presented in a slightly different way. So I did game type by sex, so let's go sex by game type and add that in there. And then I'll just scroll all the way down to the end of that output. And here we've got males and females, and we can see that the difference between male and female when it comes to non-violent video games is almost nothing. It looks like, well, in fact, that's what we found here. This is they're basically overlapping each other here. And that's what's, males and females do not differ from each other when it comes to non-violent video game playing. But when it comes to violent video game playing, you can see that there is a difference. And we can calculate Cohen's d for each one of these effects, and I talk about that in the textbook. So this is the same story. You would never present both of these charts. You'd choose one that you thought was the best way to tell your story based on the data. Now, the last thing I'm going to talk about are the estimated marginal means, because this is the sort of thing that you could end up fooling yourself. Look at the 6.03 mean here for violent video game type. Now that's collapsing males and females together, 6.03. If you go up here and you look at violent video game type, that's a 5.97 here. So irrespective of male-female, 5.97 for the violent video game. But when I looked at the estimated marginal means, I got a 6.03. It's slightly different. So let me show you how it actually calculated that. It's actually not complicated. It actually just averaged these two means together. So let's actually 7.01 plus 5.05 divided by 2 equals 6.03. Now that's a different value because it's not taking into consideration that the sample sizes are different. So when this mean here was calculated, it was calculated on all 17 cases, and each case is worth the same amount in terms of weighting in the analysis. So arguably you should be weighting the female mean more than the male mean, but the estimated marginal means do not do that. You could have a sample size of 500,000 here and 6 people here, and it would still just calculate the average of this mean and that mean. And you might argue, well, that's not fair. This sample size is so much bigger. Surely that should get a bigger weighting in the calculation of the mean. That is not how it works when you choose type 3 sums of squares. And it's important to note this because the actual ANOVA is based on the difference between these means. It's not based on the difference between this mean and that mean, or any of these means, although the interaction would be based on these means here. But the main effects are actually based on the estimated marginal means if you select type 3 sums of squares. And that's the default in SPSS. So if you were reporting the means and standard deviations for the main effects in a study, you could argue that you should report these means and standard deviation. But alternative arguments could be made for reporting the observed means and standard deviations. I'm not going to resolve this debate here. I just want to point out the difference between the two. And the charts here, I'll note, are actually based on the estimated marginal means. So this is 6.03, and that's taken from here. It's not getting the 5.97 here. So that is how you can do a 2x2 between subjects factorial ANOVA in SPSS. It's not everything. I haven't decomposed the interaction, and I haven't determined whether the main effects can be interpreted given that there's a significant interaction. I do that in another video.